move to the another section. Okay, that is acceleration. Did you heard about acceleration? I think it's a new concept to you. Okay, today we are going to study about acceleration. What do you mean by acceleration? What do you mean by acceleration? In order to understand this concept, we have to imagine that you are traveling in a car. Okay, suppose you are traveling in a car. While you are traveling, every time the speed must be equal? No, the speed varies. Okay, isn't it? Then we are changing the gear for getting high speed. Okay, we are changing the gear for getting the high speed. Okay, actually we are pressing the accelerator for changing the speed. Yes, indeed. Actually, we are pressing the accelerator for changing the speed, isn't it? So, we can say that while pressing or pushing the accelerator, the velocity is changes. While pressing or pushing the accelerator, the velocity is changing. Okay, so that process or that is known as acceleration. Okay, acceleration is the rate of change of velocity. Okay, acceleration is the rate of change of velocity. Rate of change of velocity. The rate of change of velocity is known as acceleration. Okay, the acceleration can be represented by the letter small a. We can represent acceleration with small letter a. Okay, is it clear? Then now you know the equation. Okay, look at here. Acceleration is equal to change in velocity by time. Okay, change in velocity by time. The change in velocity may be the initial velocity and the final velocity. Okay. The change in velocity by time. Acceleration is the rate of change of velocity. Acceleration is equal to change in velocity by time. Is this change in velocity include the final velocity and the initial velocity? Is it clear? Then, now you know the equation, the unit of velocity, that is meter per second. The unit of velocity is meter per second and the unit of time is second. Okay, so we can write as the unit of acceleration is equal to meter per second square. Okay, here you can see 2s. So we can write here as say a square. That is the unit of acceleration is equal to meter per second square. Is it clear? Look at this figure. With the help of this figure, we want to complete this table. Okay, first one, distance traveled by the car from A to F. Okay, we want to mark here. Okay, from A to B, B to C, C to D, D to E and E to F. Okay, then initial velocity. Initial velocity can be represented by the symbol U. Okay, then final velocity. Final velocity can be represented by the symbol V. Okay, then next column, change in velocity. Change in velocity means final velocity minus initial velocity. That is V minus U. Okay. Then time taken for the change in velocity. That is T. Okay. Next one. A is equal to V minus U. V minus U by T. A is the acceleration. Acceleration is equal to final velocity minus initial velocity by T. Okay. With the help of this figure, you want to complete this table. Okay, then from A to B. A to B. What is the initial velocity? Initial velocity is the starting velocity. I told you that in earlier classes. So, here 0 is the initial velocity. Okay, so we can write 0. Okay, then final velocity. Here final velocity is 5. We are so here from A to B. Here B is 5 meter per second. That is the final velocity. Okay. Then change in velocity. Change in velocity means V minus U. This is 5 minus 0. How much? That is 5. Okay. That is 5. meter per second. Then time taken for changing velocity, that is t. How much is the time taken? That is from A to B, the time taken is 5 seconds. Okay, so we can write here as 5 seconds. Then acceleration is the rate of changing velocity. So a is equal to v minus u by t. You can substitute these values in here. Okay, so we will get here v minus u. We got as 5 meter per second. Okay, that is 5 meter per second by the here time is 5 seconds. Okay, that is 5 seconds. That's equal to how much? We will get as 1 meter per second square. Okay, from A to B the acceleration is for 1 meter per second square. Is it clear? The next one from B to C. Here B to C. Here B is the initial velocity and C is the final velocity. Okay, so we can write B is equal to 5 meter per second. Okay. Then what's the final velocity? That is V. That is 10 meter per second. Okay, is it clear? Then V minus U, that is 10 minus 5. How much? That is 5 meter per second. Your time taken is how much? From B to C. So here 10 seconds and here 5 seconds. So we can minus it. Okay, 10 seconds minus 5 seconds. How much? That is 5 seconds. Then acceleration A is equal to V minus U by T. So here V minus U is 5 meter per second and T is 5 seconds. So we can write 5 meter per second by 5 seconds is equal to 1 meter per second square. Okay, is it clear? From B to C, the acceleration is 1 meter per second square. Okay, then C to D. Look at here. From C to D, here initial velocity is 10 meter per second and the final velocity is also 10 meter per second. So we can write 10 meter per second, 10 meter per second. Okay. So then V minus U, 10 minus 10, how much? 0. Okay. Then here the time taken, 15 second minus 10 second, how much? That is 5 seconds. Okay. Is it clear? That's also 5 seconds. So we will get A is equal to V minus U by T as how much? That is here V minus U is 0. 0 by 5. That is how much? That is 0. Okay. Is it clear? Shall we move to the next one? Then D to E. Look at here. D to E. Here D is 10 meter per second and E is 6 meter per second. Okay. Here the initial velocity is 10 meter per second. Then final velocity. Final velocity is how much? 6 meter per second. Is it clear? Then you want to subtract it. Okay, V minus U. That is 6 minus 10. We will get as 4 meter per second. Okay? Minus 4 meter per second. Okay, minus 4 meter per second. Then here the time taken is how much given here? That is 20 seconds minus 15 seconds. Then we will get 5 seconds. Okay, so we want to find A is equal to V minus U by T. When putting these values in V minus U by T, we will get as minus 0.8 meter per second. Minus 0.8 meter per second square. Okay, is it clear? Then from E to F, here E to F, E is 6 meter per second and F is 0. Okay, here E is 6 meter per second. Then F is 0. So V minus U is how much? That is how much? 0 minus 6 seconds, 6 meter per second. That's equal to minus 6 meter per second. Okay, minus 6 meter per second. Is it clear? Then here the time taken is also 5 seconds. That is 25 minus 20. That is 5 seconds. Okay, 5 seconds. Okay, then we want to apply this into acceleration. So a is equal to v minus u by t. Okay, while applying we will get minus 1.2 meter per second. Okay, minus 1.2 meter per second. Sorry, second square. Okay, is it clear? I think all of you got it. So from this we studied about acceleration. What do you mean by acceleration? Acceleration is the rate of change of velocity. Okay. So acceleration, we have an equation for finding the acceleration. A is equal to v minus u by t. Okay, is it clear? And the unit of acceleration is meter per second square. Okay. Look at here. Here you can see some situations based upon accelerations. Okay. Situations in which acceleration occurs. Okay, first situation, the motion of a coconut falling from a coconut tree. The first situation is the motion of a coconut falling from a coconut tree. Okay, second one, a moving ball coming to rest. Okay, third one, the motion of a ball rolling down a hill. Okay, these are the situations in which acceleration occurs. Okay, it may happen in other situations too. Okay. In your textbook, you can see a question and read the question, okay? A food packet dropped from a helicopter reaches the ground in 5 seconds. Okay, if the velocity with which it hits the ground is 50 meter per second, then we want to find the acceleration. Okay, look at here. Here you can see t is 5 seconds, u is 0 second and v is 50 meter per second. Okay, that is given in the question. Okay. We want to find the acceleration here. We have an equation for finding acceleration, that is a is equal to v minus u by t. Okay, here v is 50 meter per second. You can substitute it. Okay, 50 meter per second. Here u is 0 by 10. T is 5 seconds. Okay, so we will get as 10 meter per second square. Okay, and here the acceleration is 10 meter per second square. Is it clear? Next we move to another topic, that is retardation. Did you heard about retardation? Do you know what do you mean by retardation? Okay, I think retardation is a new concept up to you. Acceleration is the rate of changing velocity. Okay, when we want to slow down the car, okay, we apply brake. Okay, and retardation is the negative acceleration. Okay, retardation is the negative acceleration. We can call retardation also as negative acceleration. Okay. The unit of retardation is also meter per second square. Okay, for example for retardation is a moving ball coming to rest. Okay, example, a moving ball coming to rest is an example for retardation. Okay, is it clear? Suppose when you are traveling in a car, the velocity of the car decreases when we press the brake. Okay, that is known as retardation. Is it clear? Once again, suppose when we are traveling in a car, the velocity of the car decreases when we apply a brake. Okay, that is known as what? Retardation. Okay, we can call retardation is also as negative acceleration. Example for retardation is a moving ball coming to rest. Okay, these are about today's class. Thank you.